So this is Lab 5, Part 2. So I'm going to discuss any changes I made from Lab 2 to facilitate using interrupts rather than polling in order to read the button values and to trigger when a button value is read. So essentially, I moved all variables to global variables. They could be used by each of these functions, including the interrupt handler functions. So we have the window input and alarm input, which is where I read the value from switch 1 and switch 2. And then the status buttons, which updates the status of the window and alarm based on how many times window is pressed or alarm is pressed. So the only changes I made to the configuration was in the switch configuration function. And here I set both the port 1.1 and 1.4 to falling edge events. I cleared their interrupt flags and then set interrupts on both ports. And this line of code sets their priority to 2 and enables interrupts on port 1. So these functions are from the old code. They just read in the value of both the switches, the window and the alarm. And then, so I use systic to actually flash the red LED when the alarm is active and the window is open. And the way I do this is I use the 48 megahertz clock. I just turn if both these conditions are met, which are determined by the other handler, port 1 handler function, it'll turn off the green LED, toggle the red LED, and turn it on and off at 5 hertz by making the systic wait a period of 10 milliseconds. The reason I use a systic handler is just because it simplifies flashing the red LED, and it's done periodically by the systic function. So as long as these conditions are not met, the red LED will not flash. But as soon as these are met, it'll begin to flash red. So this is the port 1 interrupt handler. And this is where I read the values for the window and the alarm. And then all this other code is taken from Lab 2. It has not changed. The only thing different is instead of flashing the alarm here, that's handled by the systic timer based on the values that are updated here. So if they're updated correctly, then the systic handler will read that update when both the statuses are 1, aka open or alarmed, and it'll start flashing the red LED. And for this handler, the port 1 handler, I actually have to acknowledge the interrupt, but for systic, that's automatic, so I don't have to acknowledge it. In the main function, all I do is configure the LED and switches. I initialize the clock in systic in between the disable and enable interrupts. And then I just essentially wait for an interrupt to occur from the board. And the systic function will actually always be generating periodic interrupts, but it won't do anything unless the statuses for both the buttons are correct, or are correct in that case. So I'm going to compile and run this on the Launchpad and demonstrate it's working. Okay, now it's loaded. I can run it. And as you see, the green LED is on when the alarm is active, or sorry, off. If I press the button, it's armed. If I trigger the window, it starts flashing at a period of 5 hertz. And then if I press it again, close the window, it stops flashing. And if I press the arm button, it becomes unarmed at the green state. I'll show you again. It's armed, flashing at 5 hertz. And I can press the arm button again and it'll stop flashing, like so. And this flashing is handled by the systic handler.